Hello friends, I am Aditya Patil and we are going to study the one of the topic of the physics which is relativity. Relativity means a relation between the two things. Most wherever we go, we try to attract some sort of relations. For for example, if you are standing here, standing on the east hand side, so for the person who is standing on the west hand side, you are standing towards his east. But for the same, for you, if you look at the person who is standing more on east side, for that person you are standing towards his west. For example, look at this. I am standing toward here. This is my right hand, and if I one person is standing on this side, for that person I am standing towards his right side. But if the same person travels and goes on this hand side, for this person standing here, for that person I am standing towards right hand side. So look at this. For the same people, if he moves here and if he stands here, the same I am standing, for example, here. For that person I am towards his right hand side, but for this person I am towards his left hand side. Means each person, wherever he is, he has his own perspective or point of view of thinking. For if you are standing on the ground and if you are looking towards the aeroplane, for you the aeroplane is very high above and it is towards your vertical axis. But if the same person from the aeroplane is looking towards you, for him you are standing very low. So both of you have different types of thinking. If you travel, if you are traveling through a train, you observe that the people around you, when you see out of the window, the people, the objects and things are moving, and you feel that all the things are running from the window and a type of stream is going on. So at that point, how you feel that? Because at that point you think that you and your train, the coach in which you are sitting, is stationary, means at a particular fixed position. And so as per your thinking, these things are moving. But at the same time, if your friend is standing outside the train and if he looks at you, he will see that you are moving along with the train. So he will say that you are moving because he is standing on a stable ground which is fixed position, and according to him you are failing. So in this way we are going to say relativity. Relativity means relation between the two things. Now you are going everywhere. Sometimes in a classroom, for example, in a classroom, if the fan is not running, some people will feel that classroom is normal temperature, other people will feel that it is hot. But some, if the particular person has a fever, then he will feel that the classroom is cold. So look, for the person who is having a fever, for the person the same classroom is very cold. For a normal person who is adjustable in this temperature, for him this classroom is normal and he doesn't require anything. And for the person who is feeling hot from his side, the classroom temperature is higher. So means as per the thinking and as per the measurement of a particular person or particular instrument, the surrounding things also changes. For example, if you and your friend are sitting in a car which are running with the same speed, so you will feel that the car, your car and his car is along, so you will feel that his car is also a stable position. But for your friend who is standing on the ground, you are moving along the car with a particular velocity. But on a second point of view, if you and your friend are sitting in a car which are moving exactly opposite to each other, so the velocity get doubles. So such kind of view, as per our thinking, it changes. Now in relativity, first of all, we'll know, as I said, that for a particular person who is thinking about the other object or other situation, for him he is thinking that he is at a stable state. So for that stable state, the term is used or the stable state, the term is used as initial frame of reference. As I said before example, for you, if you look at an aeroplane, then it is a moving and it is high above you, because you are considering yourself as an inertial frame. Inertial frame means the point from which you are measuring something. So as your inertial frame is that ground, so for you that aeroplane is very very high. But the person who is sitting in the aeroplane is thinking that he himself is stable or he himself is right. So for that person, the ground is very very low and you are standing low. Many ways in our normal life also, what do we think that our point of view or what we are thinking is actually correct, and we judge a person according to it. For example, if you are a serious person or you are a silent person, so for you a little bit playing boy is mischievous, but according to that mischievous boy you are silent. So each one is thinking as per his. So in physics we have inertial frame of reference, means the frame of reference which we are considering stable or in which we exist and we think that it is correct. And the the other frame of other thing which are measuring are relatively considered according to us. Now normally the inertial frame of reference is denoted by S frame. S frame means inertial frame in which we are standing, and here we think that everything is stable, and here the terms means we want to define that exactly where I am standing. For example, if you are sitting in a class, how do you know? How will I know that where the person is sitting? So if I example says the person, I says call that person, but you will get confused that which person should call. Then I will say that a person sitting in particular row and a particular number of bench. Huh? And so when I will specify that person in such a way, you will get to understand that which person I want to call. In same way in inertial frame, in particular frame, if you want to define the position of a person at particular place and particular time, we'll use the place and time coordinates, which is x, y, z, t. Now as we say that as we consider ourselves as a stable or inertial frame, and we are then considering the other person or other situation as per our thinking, so that other situation is non-inertial frame of reference. Now look, in this classroom everyone has a different physical appearance, means that their xyz coordinate differs. For example, if a shorter person with a less height stands by side a person A, if a person A has a height of 6 feet, as but the person B has a height of 5 feet. For if we consider person A as inertial frame, so for person A, the inertial frame will be as we are just talking about the height, so height is a y-axis, let us consider, and from the person in inertial frame, for him height is 6 feet, so for him the person B, which is 5 feet, he is 1 feet shorter, or we can say towards negative y-axis. So for that 6 feet person, 5 feet person is toward negative minus 1y, but for the person B, who is of 5 feet, for that person, as 5 feet person will think that he is on a stable position, so according to him the 6 feet person is above means plus 1y. Now as we know, non-inertial frame means which we are considering that ourselves we are stable, so as compared to the frame or the thing which we are measuring are non-inertial frame, and in that case we write them as S dash frame, and the coordinate are written as x, y, z, t, like this. Means we are symbolically representing them. Now we will consider just one axis for now, as this topic is new for you. We will consider only x-axis, because normally when you move from one point to another, we are moving only in xy plane, and when we go higher, for example in the aeroplane or when you jump, then the z-axis is considered. Now if a car is moving along x-axis, for the person sitting in the car, he is stable position because he is moving along with the car. But for the person who is standing on a road which is stable, the car is moving toward x-axis or changing its direction. So according to person who is standing on the road, how the car is changing. So for the person standing on a road, position of the car is, as it is only moving toward x dash, so here position of the car, let's consider x dash, here it is, he is standing on position x, x. So the position of car is from moving from x to x dash. So distance x dash minus x is covered, and it is covered within a time interval, or and as well as with the velocity of car. So it is written as x dash is equal to x minus vt, where t is a time required for that car to move from this person where is standing to this point x dash, and time and velocity v is velocity car. Now look, the car is moving only towards x dash axis, so only x dash is changing. At that time, the time will not change, because for that person, if the person is standing here, for the person standing on the road, in his clock the time is shown as, now what is the timing, 1 a.m. So for the person sitting inside the car, the time is also 1 a.m. because time is not changed. Time is according to day and night, and it is according to motion of the earth, so it will not change. So t dash will equal to t. Okay, look here, only x axis is changing, means the distance is covered by x axis, so x dash is changing. Time will not change in both the clocks sitting car, as well as the car is not flying like an aeroplane in upward direction, nor the car is moving here and there. We are still now considering the car is moving a straight road. So here y dash will be y dash and z dash will be z. In such manner, inertial frame means the frame which we are considering is correct or stable, and the frame which is we are want to measure is non-inertial frame as it is moving. So okay, this is clear. Now look, what do we see today? Relativity means we want to make a relation between the two objects or two situations. As I told you, if you are sitting inside a classroom, for some people the classroom will be high temperature because they are feeling some kind of hotness, means their body temperature is less than the room temperature, and so they are feeling hot. Some people will feel normal because their body temperature is same as the temperature of the room, and they are comfortable with that. And for some people it will be cold, because for example we feel cold because when we have fever. In fever, our body temperature rises above the normal room temperature, atmosphere temperature, and that's why we feel cold. In such a way, according to each person, the frame is changing. For example, here I am standing. For some of you, it will be that the person sitting on a first bench will feel that I am just 1 feet away from him, or 1 feet towards his particular XY axis. But for a person sitting on a last bench, he will feel that I am a particular 6 to 7 feet away from him. In the same way, we are trying to make relationships between these. Now, inertial frame. Inertial frame means which frame or which a condition or a position which we consider a stable as per the S frame. It is known as S frame. Its coordinates are defined by x, y, z axis. Non-inertial frame, S dash frame, x dash, y dash, z dash, t dash. For a person, I example gave. If a person is 6 feet high, for a person who is 5 feet high height, so for him he is 5 feet minus 5 feet towards downwards means minus y, 5 feet y. But if we consider, here we have considered So for a person who is 6 feet high, the 5 feet person is minus 1y. But for a person who is 1 feet, for a person who is 5 feet high, for him the person 6 feet high will be towards plus y, plus I. In the same manner, we saw this as a car is moving in a particular road which is a straight. So as today this is topic is new, we will consider only straight road. For a straight road, we will consider only a x-axis toward moving, and a person is standing on a road who is considering that he is stable. Consider he is stable, and for him the car is moving on x-axis. So as the car is traveling with velocity v and it completes a particular distance in particular t, so this can be also be written as distance is equal to x dash minus x is equal to vt. As we know, speed is equal to distance upon time. So according to it, as I told, for a person standing on a road as well as sitting inside the car, the time will not change. In his clock also the time will be 1 a.m. and his clock also same 1 a.m. will be there. But as well as the car is going along a straight road, so y will not change and z axis will be also not change. So y dash will be y and z dash will be z. Okay, okay student, thank you.